Welcome to Group 23's Introduction on Least Recently Used Algorithm, LRU. LRU is a page replacement algorithm that aims to reduce page fault rate by replacing the page that has not been used in the most amount of time in the RAM. Let's take a look at an example. Assume 4 frames within this simple memory system. Should a requested page not be present in the frame, a page fault will occur and the least recently used page will be swapped out for the requested frame. In the top right, we have the reference string, which is the order in which the user wants to access pages, and the LRU tracker that keeps track of the least recently used page. The first requested page is 1. A page fault occurs as it is not within any active frames. Page 1 is inserted into frame 1 and the LRU is updated to 1. The second requested page is page 2. A page fault occurs as it is not within any active frames, and page 2 is inserted into frame 2. The next requested page is 3. A page fault occurs as it is not within any active frames. Page 3 is inserted into frame 3. The following requested page is 1 again. A page fault does not occur as page 1 is in frame 1, so the OS can simply access it. After accessing page 1, the LRU is no longer page 1 but now 2. Next up is page 5. A page fault occurs as it is not within any existing frames. It is inserted into frame 4. The next requested page is 3. It currently exists in frame 3 and is accessed. Page 2 is now requested. It exists in frame 2 and is accessed. LRU is now updated to 1. Page 6 is requested. A page fault occurs as it is not within any of the 4 frames. The least recently used page, page 1, is swapped out and the LRU is updated to 5. Page 3 is requested and accessed in frame 3. No page fault occurs. Now page 7 is requested. A page fault occurs as page 7 is not within any of the 4 frames. The least recently used page, page 5, is swapped out and the LRU is updated to 2. Page 1 is requested. A page fault occurs and page 1 swaps with the LRU page 2. LRU is updated to 6. Page 6 is requested. It is accessed from frame 1 and the LRU is updated to 3. Page 5 is requested. A page fault occurs and page 5 is swapped with page 3. LRU is updated to 7. Page 8 is requested. It is swapped in with the LRU, page 7. LRU is updated to 1. Page 8 is requested again. It is accessed in frame 4. Page 1 is requested and accessed from frame 2. LRU is updated to 6. Page 2 is requested. A page fault occurs and it is swapped with LRU page 6. Page 5 is requested and accessed from frame 3. LRU is updated to page 8. Page 1 is requested and accessed from frame 2. Page 2 is requested and accessed from frame 1. With that, the user has no further requests and the example is complete. Now that we know how LRU works, here are some advantages and disadvantages. The benefits of LRU are that LRU has severely reduced page faults compared to its counterparts like first in first out or random replacement. It has constant time operations such as get and put, and it does not suffer from Baladi's anomaly where more page frames lead to more page faults. As for the drawbacks, we have that LRU suffers from poor performance when access is unpredictable, leading to increased cache misses and thrashing. Next, tracking the LRU involves some overhead, such as by tracking and adjusting LRU in the linked list, especially in large caches. Lastly, LRU does not account for frequency of use, leading to potential increased cache misses. Now that you know all about LRU, are you ready to put your skills to the test?